Welcome back. We're now at section 2.4, and today we're going to write linear. Last we spent time graphing linear functions. Now we want to actually write those linear functions. And so one thing to keep in mind is our slope-intercept form that we talked about, where the number in front of the x is the slope, the number by itself is where it crosses the y-axis, it's the y-intercept. So by looking at a graph here, all we know is those two things. So we're going to go y equals, and first thing I do is pick out the y-intercept. Here we can see it's 1, so just go plus 1. And now this line is a negative sloping line, so I'm going to put a negative, and let's just kind of count down. 1, 2, 3, 1, 2, 3, 4. So the rise, it goes down 3 into the right 4, so our slope is negative 3, 4. So there's our equation of our line, and there it is. Yeah, it's like working backwards here a little bit. All right, let's try this one here. All right, this time we have a positive sloping line. And once again, we can see that our y-intercept is positive 3. Now the slope, again, I would go up 1, 2, 3, and to the right 1, 2, 3, 4. This time it's a positive 3/4 slope. Okay, so again, you could be able to figure that out very easy by the graph. Those two things, you got to figure out what your slope is and your y-intercept, and then you're good to go. Okay, so again, keeping in mind different ways of finding the slope. You can kind of think of it as the change in y or the change in x, the rise over the run. Or basically, if you have 2 points, you can just subtract the 2 y values, and on the bottom, subtract the 2 x values. Just make sure you're doing it consistently from the point to point. Okay, so let me show you how that works. Again, as we go here, let's see, here's our slope. So again, what we can do is we can find the slope by taking y2 minus y1, x2 minus x1. So doesn't matter which way you go, let's just go this way. Let's go negative 5, subtract 1. So if I started this one for the y's, I got to do the same thing for the x's. So we're going to go 2 minus a negative 1. And again, we get negative 6 over 3, which is negative 2 for our slope. And if you want to leave it as negative 2 or negative 2 over 1, that's fine. It works either way as we go. Okay, so finding the slope that way, certainly something you can do. If you have a table of values, basically you take the change in y. So what's happening here? We had a plus 3. Here we had a plus 4. So our slope is simply 3/4. And it doesn't matter which ones you use. You can use this one too, because obviously that's 3 over 4. And just pick any 2 points that you want to, and you've got your slope. Pretty nice. All right. Now, question. We'll try a tricky here. What's the slope of this line? Well, the slope of this line, well, look at that. There's no rise, is there? Horizontal line, hold on, remember that slope is 0. 0 is the slope of that line. All right, what about this one? All right, so let's do the change in y. Negative 5 minus negative 5 over negative 3, whoopsie, minus 2. Well, here we get 0 over negative 5. Remember, 0 over anything is 0. Remember, this is a horizontal line. Again, that would be a slope of 0 as well. Now, if you had it the other way around, if it was negative 5 over 0, that would be undefined. Remember, we cannot divide by 0. 0 can never be in the denominator. All right, another type of form besides slope-intercept form is point-slope form. And this is really handy to have. Again, if we give a point, if we know a point that's on a line and we can figure out the slope, we can put it in this form right here, by taking y minus the y coordinate equals the slope, and then x minus whatever that x coordinate is. Okay, and I've got it on the board over here. We'll refer to that as we're working on the next few problems. All right, so here we go. Let's take this. Let's write the equation of a line that contains the points. Okay, well, let's choose a nice easy point. I try to stay away from decimals and negatives, so I'm going to choose 8, 1. You can choose any one you want to, but using point-slope form, what we would do is we go y minus the y coordinate, which is 1, equals the slope. I'll come back to that in a second. And we're going to go x minus the x coordinate, which is 8. Now again, we could have done y minus a negative 5, which would be y plus 5, and then x minus a negative 8, which would be x plus 8. We could have used this point as well, or any of them. But let's try to find the slope here. The slope is the change in y, and you can do it between any two. This works out pretty good here. If I choose there, negative 3.5 to negative 5, that's going up 3. At the same time, it looks as if we're going up 8. So our slope is going to be 8. I'm sorry, 3/8. All right, well, did say they wanted slope-intercept form, so we got to get the y by itself. So we're going to go y minus 1 equals, we're going to distribute 3/8 x that works out well. That just becomes minus 3, the eighths chunga chunga. Then just add 1. Y equals 3/8 x minus 2. There it is in slope-intercept form. If it doesn't say to put it in slope-intercept form, you can just leave it like that. But more often than not, we want it in that slope-intercept form. Okay, so there we go. So that's using that slope, that point slope form. That's kind of a good one to use. Now, a couple other things. We'll use that again here a couple times. And what we're going to do is we're going to use this for parallel lines and perpendicular lines. If we know two lines are parallel, that means they're going to have the same slope. The same slope. If they're perpendicular, if they intersect at 90 degrees, their slopes are going to be what we call opposite reciprocals. So this slope is 2/3. This slope of the perpendicular line is going to be opposite and flipped. It's going to be -3/2. That's how they intersect at 90-degree angles. Okay, so remember that as we work ahead here. All right, so let's try this. Write the equation of this line that's parallel to this line and goes through the point 5, 2. So let's use our point slope form. We're going to say y minus 2 equals, and then here we're going to have x minus 5. Now, we know if it's parallel to this line, it's going to have the same slope. So 1.8 is the slope. So y minus 2 equals 1.8x minus 9 would be the case there. And if we added that 2 to the other side, we'd have y equals 1.8x. That would be minus 7 is what we'd end up getting there for the line that goes through there. Okay, so good problem to have there, set up. Okay, let's try one where it's perpendicular. Okay, so here's an equation of a line, and it is perpendicular to this line. It goes through the point. Now, here we go. We're going to go y minus a -2, so that actually makes it plus 2. And then here we're going to have the x minus 9. So if it's perpendicular, we got to flip it and change the sign, opposite reciprocal. So the slope of a perpendicular line to this one would be 2/3. Y plus 2 equals 2/3 x minus 6. If I subtract the 2, 2/3 x, we go minus 8 is what we end up for the line that we have there. Okay? All right, well there we go, lots to do there. Again, remember our slope-intercept form and then the point slope form. That's kind of a nice one to kind of put some things into. Remember, to get it to slope-intercept form, just solve for the y. All right, that's it for 2-4. Until next time, I'm Mr. Boone.